Hi, Jagrati. Hope my voice is clear to you. Can you please confirm?
Yes, sir, your voice is clear. Okay, so good evening, everyone. I hope you all are good and fine. So, a very warm welcome to all the respected speakers, our program coordinator, Dr. Neha Khurana ma'am, and to all the participants in today's session of AICT ATAL FDP on advanced computing organized by UIET MD Rohtak. So it's give me a great pleasure to introduce our first speaker today, who is Mr. Anuj Gupta sir. So sir is the co-founder of D2O Learning and partner at Design to Occupancy, and he holds a degree in electrical engineering from Birla Institute, Pilani, and has completed a management development program from IIM Lucknow. And he is a renowned sustainability expert with certifications including lead AD, APBD plus CH expert and auditor, GRIHA, IGBC and ECBC. Through his work, he actively contributes to green buildings, energy efficiency and sustainable development initiatives. So we are delighted to have Sir with us today. So now I invite Sir to please take over the session.
All right. Thank you so much, Jagrati. Thank you so much, Dr. Neha, for inviting me for this faculty development program. Hope my voice is clear, my video is clear to everyone. Can everyone confirm in the chat box? I think everyone has access to the chat box. So let me just check if it is. So I request everyone. We will be making this sessions next 90 minutes very interactive. So I would request everyone who are here with me, just type I am here in the chat box. Everyone just type I am here in the chat box if you are if you are listening me, if you are attending this FDP session. I request everyone to just type I am here in the chat box so that I can connect with you and I can see that you are here with me. I think continuous chat is off. Okay. Can anyone confirm in the chat box if you're here with me? And I'll start my presentation. All right. Hearing, I am not able to see any messages in the chat box. I request all the people who are
Sir, it's
okay.
clear. Your voice is also clear and your camera is
No,
also.
that is fine, but I want everyone attention for the session, so that's why I'm checking with everyone like who all are here with me. So everyone just type because we will be making the sessions very interactive. It will not be the one-to-one. It will not be just one-way communications. I'll try to make it two-way communication. So I generally, when I do the session, I interact with the participants in the chat box. So I got a one thumbs up. Thank you so much, Ms. Pooja, for giving me a thumbs up. Like you are able to, you are here with me. Everyone just give me a thumbs up or you just type in the chat box if you're with me. Then I'll share my presentation. And the topic is very interesting. Have you people heard about, I think topic is a digital twin. Can anyone just give me the heads up in the chat box? Have you people heard about the topic called digital twin? Because the theme of this FDP is advanced computing. So I thought what should I present to you? And I think what will be very helpful for you. So this FDP is organizing by Department of Electrical Engineering, and I'm also electrical engineer. So I also did my electrical engineering. So that's a pleasure to be here, like with all the faculties who are present here to share my insights, not only specific to electrical engineering, but yes, related to in which domain I am working, and I think that would be very helpful for you also. So. Can I start my presentation? Let me just share my screen and then I'll start. So next 90 minutes till 7:30, I will be covering my session. And if you come across anything, any questions, if you have, please feel free to ask in the comment section or you can unmute yourself. Okay. So give me a minute. I'm just sharing my screen. All right. Okay, so the topic name is digital twins, making building smarter and more sustainable. So I am working in this industry called sustainability industry. I completed my education as an electrical engineer, then did my like a management development program from IIM Lucknow. So I thought like, what should I present to all the people who are coming for this FDP? So I thought like digital twin is a very important subject. If we talk about the advanced computing, we are very familiar with now AI, generative AI, LLM, and all. But how the future belongs to, like, what are the how we will be using or how we are using this uh, artificial intelligence and the machine learning in application and different applications. So digital twin is one of the things where we implement these things so that we can do a lot many things. Okay. So this making building smarter and more sustainable. So it is happening at many places, and I will be sharing various examples also. But before that, I'd like to share a brief about me. So I'm a partner at Design to Occupancy, and I'm a co-founder of D2O Learning. Apart from that, I think Jagati mentioned that I'm a lead APBD plus C. So it's one of the credentials which is required if a person is wants to work in the sustainability industry or want to be a sustainability professional. I'm a Edge faculty. I conduct a lot of Edge expert training to the people who wants to become the Edge expert. So that training also I conduct. I'm an Edge auditor, Edge expert, and multiple credentials. So it's you also, like as a faculty, as a resource person, if you people also wants to become this kind of a credential holder, you can also learn these things through different platforms. Okay, so I will be also sharing few things during the this session. So first of all, thanks to the organizing college as well as ATAL and the AICT for giving me the opportunity to interact with all the people who are present here. So but today we will be learning about digital twin. So moving forward, I have a questions to you. Do you people use smart devices or like a smart watch, smartphones? Just type yes in the chat box if you use smart devices for your regular day-to-day activity or your work. Okay, Bhavya is saying yes. I request everyone just type if you use smart devices, smartphones, smart watches, anything, any smart things that you use. I request everyone to just type yes in the chat box if you do that. So Pooja is doing that. Great. Okay. I request other people. I think we have around 24 people in this call. So I need attentions from everyone so that I can give my best and I can take your best also. Super. Okay. So a couple of people are using. So what these smart devices does? Okay. So they track our data. Okay. So Puneet is also saying yes. So they track our data, and on that data, on the basis of that data, they analyze our work, like how we are working as a, and give the recommendations also and suggestions. Okay, how you should do it. Okay, so as well as we can also track, we can monitor our health and fitness also, like if you are using the smart watch and all, and accordingly we can work on it. Okay, so like that kind of a thing, we can say the predictive health analysis that we can do. Okay. Similar thing happens in the buildings and infrastructure. Okay, so as might be you people belongs to different departments, electrical, mechanical, civil, architecture, anything, anywhere. But yes, how this thing will be helpful for you. So that we will be learning how it generally happens in the infrastructure side. So we will be using the similar pattern, like smart devices we use to track our health and data. Similar things we will be using in our buildings and all. Okay. So why this topic matter? When I was selecting this topic for the theme, advanced computing, so the main part of my selection is buildings are becoming data generating systems, not static assets. I think you are familiar with this. If you are, we as a human, we spend our 90% of the time, 90% of the life inside the building. Okay, inside the physical structure. So that is called our home, office, okay, your college, your campus. Okay, so 90% of the time we spend inside the building. So that buildings play a very important role in our life. Okay, so buildings are becoming data generating systems now. Earlier we used to make a conventional building. We generally do not put more in it was not impacting a lot many things, but now buildings are impacting a lot of things. We are talking about the carbon emissions, we are talking about the climate change. So those things are impacted by constructions on the building. I think you heard about the air pollutions in North India, especially in Delhi, which is happening because of lot many construction activities, lot many traffic movements and all. Okay, so that's the reason. So that's why the buildings are very important, and now they have become data generating systems, not static assets. They are not static assets. We are getting a lot of data. What are the data? I will be covering in the next slides. The next part of the topic is sustainability goals demand continuous performance, not just design intent. If we talk about the sustainability, it's not just yes, we have to make building green and sustainable and all. एक और चीज मुझे पूछना था, is Hindi, English, both languages fine, or which language I should prefer? Everyone just type your preference of language so I that give my input accordingly. Both are fine. Okay, great, super. So I will be covering in both languages. So because I know only these two languages. Okay. So sustainability goals demand continuous performance. What happens when we talk about sustainability? It's not just we have to think about it, and in the design stage we have to focus on the sustainability, but it is a continuous process. It is a performance based also, like how you are doing right now. It will impact your future also. Okay, similarly happens with the sustainability. So it's a continuous process. So that we are going to discuss in the sessions today. The next is traditional tools stop at design. Digital twins continue through life cycle. So जो हम लोग पहले tools use कर सकते थे वो stops design stage पे stop हो जाते हैं for an infrastructure, for a building. But digital twins continue through life cycle. So it gives the data real time. We work on the real-time analysis. We do the real-time analysis and all through digital twins. Okay, that we are going to discuss. So that's the importance of this topic which we are going to cover today. So the future of building is predictive, adaptive, and intelligent. Okay, हम लोगों ने बात किया स्मार्ट वॉचेस. पहले ये चीजें नहीं हुआ करती थी. पहले स्मार्ट डिवाइसेस नहीं हुआ करते थे, स्मार्टफोन्स नहीं हुआ करते थे. But now these are in places. And in future, as AI is also booming right now, that things are moving very fast. Okay, similarly in our building also जो पहले हुआ करती थी उसी की डिजाइन अभी हम very smart buildings पे काम कर रहे हैं. We are developing, making a very smart buildings, luxury plus a smart both, as well as I mentioned, data generation. So your data is very important. Your building data is also very important. So to predict the future, to predict the next what is the next future, as well as adapted, how you can adapt. You can see the lot of disasters are happening like in India on a we can see during summer, winters and all. So how we can predict the impact of that disaster, as well as how we can predict the future, so that the building should be adaptive, resilient होना चाहिए, as well as intelligent. Like we talk about Siri, ChatGPT and all. So similarly, our building should also work on that. So that's the future of buildings, and on that I think all the AI, ML and all, whatever the things we are, these things are used to make a building smart and sustainable. So the next thing is evolution of building. So we will be seeing what is the past, in the past, how the building look like, the present and the future. Okay, and you can also put your questions in the chat box if you come across. So the past, it's a static building. रिएक्टिव मेंटेनेंस, बहुत ज्यादा मेंटेनेंस रिक्वायर्ड होता है. अगर आप किसी भी पुरानी बिल्डिंग की बात करें, इट्स अ वेरी स्टैटिक बिल्डिंग. वहां पे देयर इज नो स्मार्ट मीटर्स, देयर इज नो मैं अगर लेमन लैंग्वेज में बात करूं, पुरानी बिल्डिंग तो हमारे पास लिफ्ट भी नहीं होते, ना स्मार्ट मीटरिंग, ना स्मार्ट वाटर मीटर्स, नथिंग. मतलब हम डेटा की तो बात ही नहीं कर सकते. लोगों के घर पर मीटर्स भी नहीं होते. स्मार्ट की तो बात की बात है. मीटर्स आर आल्सो नॉट देयर इन द old conventional building. Okay, and there is a lot of maintenance are required. Okay, so the life of building was not good. But today, if we talk about the present, smart buildings are there. Dashboard and automation have come. Like we have a lift, we have automated systems in our buildings. We have now smart meters also, which can track our energy data. We have a smart water meter also, which can track our water data, like how much water we are consuming in the building, as well as indoor the air quality monitoring. We are talking about इंडोर एयर क्वालिटी की. हमारे पॉल्यूशन बहुत ज्यादा है, जिससे कि हमारा इंडोर का पीपीएम लेवल बहुत ज्यादा बढ़ गया है. ठीक है, पॉल्यूशन. तो अभी हमारे पास दैट purifier आ गए, पहले ये नहीं हुआ करते थे, that was not there earlier. Now we can track what is the ppm level in our inside and outside thing. So now the things have been smart enough, and we can track everything in our mobile application also, कि हमारा energy का कितना consumption हो रहा है. We can, from the mobile itself, we can switch on the AC, switch off the light, everything we can do today. Okay, it's happening. Automation is in place. But what will happen next? What will be the future? So that is also very important. So the future belongs to buildings that learn, predict, and optimize themselves. Okay, let me just give an example. You are using in your house, you are using air conditioning system. Okay, and that air conditioning system runs on a different set point, like on which you generally you set 24, 25 degrees degrees Celsius temperature. So it will learn your comfort temperature. It will learn like what is your human experience. Like आप उसको कितने temperature का set करते हैं, what is your familiarity, as well as it will predict the future कि on next आने वाले महीने में क्या outside temperature होगा, and what is the requirement of the person. It will automatically optimize their set point temperature and give you the at a very comfortable temperature पे, और which is energy efficient तरीके से आपको work करेगा वो system. So that's how a building work, the systems and the buildings will be working in the future, and it is already started. So that's the future. It will analyze the data, it will predict what is going to be next, and automatically optimize the results, optimize the working. So that is the future, and that's somehow related to our digital twin. Okay, मैं एक बार system की example दिया, but similar thing happen in our digital twin also. I'll give you some more examples. So hope you are clear about the past, present, and the future. Just type PPF. Everyone just type PPF in the chat box. Past, present, and the future. If you are clear about the buildings, just type PPF. Past, present, and the future. And I'll go to the next slide. So thank you so much, Bhavya. And I would appreciate if you people type and show your commitment to your activity that you are with me on this call through comment. Okay, I know you might be traveling, you are not able to speak, but comment is the place where I get some energy from you. Like, you are with me, you are listening me, so I'll give my 100% according to that. Great, Bhavya, thank you so much. Everyone type PPF if you are clear with past, present, and the future of the buildings. All right, so I'll move forward. So shift is happening, monitoring, we monitor the data, intelligence, through AI and ML. Accordingly, we are taking the decisions. Okay, the monitoring is happening, the AI ML, the things are working, the systems are in place, predictions are happening. Decision, it will help to make the decision best. Okay, so that is how the shift is working. The shift is in place. So what is digital twin? Anyone has an idea what is digital twin? You can unmute yourself if अगर किसी को कोई पता है what is digital twin. Just unmute yourself and share some of your thoughts. Anyone?
Sir, it's a virtual replica of a physical system or device.
Yes. Very nice. Anyone else? So Bhavya, you are from, like, what's your background?
Sir, I am from MDO itself and as a student coordinator.
Okay, student coordinator. Great. Great, Bhavya. So it's a virtual replica of any system, of any infrastructure and all. But today we will be like discussing about the infrastructure buildings, like the digital twin of a building and all, and how it is happening, how different cities and the countries are working on it. Okay, so so digital twin is a virtual replica of a physical building. I am talking about only building specific, but it can be for anything. Okay, it can be for any system, any equipment, any product, anything. But it is a here we are talking about the buildings. So a virtual replica of a physical building, like if you are living any home and your commercial building, your college campus. So similarly, you can create a virtual replica of it, continuously updated using real-time data. Okay, this is very important. It continuously updated using real-time data. How much energy you are consuming? Okay, how much water you are consuming? What is the air quality? What is the indoor air quality? How the materials, things, and all, everything will be updated regularly in the system in a virtual replica and used to simulate, predict, and optimize performance, so that we can save energy, save our money, as well as lot many things. Okay, so digital twin, it's not just a model, not just a BIM. Okay, it's a living system. We can call it as a living system. So here BIM is a building information modeling. I think you people must be aware about it. So BIM is a building information modeling. So it's digital twin is different from simulations. Digital twin is different from building information modeling. It's a totally a living system. We can call it a totally a living system. So we'll discuss more. So the term digital twin, you can make a note on this. The term digital twin was firstly recognized, firstly came in picture or came in effect in 2010 in a NASA report by John Vickers. So he published our report, technical report. In that he used the term called digital twins. Okay, so since then it is being used in different areas, different things. Okay, so here you can see we have a left side, we have a physical building, and on the right side we have a digital twin. It's not a physical, it's a virtual replica of that building. Now from left to right, the data is getting, okay, like from the physical building we are getting all the data, and in the digital twin we are doing whole different models are there, data analytics is happening, and data management. Similarly on that, when we are analyzing the data and all, the decision is getting the decision is taking place, and information and decision is going, and accordingly system is getting optimized in the physical building. Okay, so that happens through different language models, as well as different things, different tools are being used. Okay, I will be sharing some tools names for the same. So this is the flow of digital twin, how it works. So this is specific to the building, but it can similar things for equipments from different systems are there in place. So you can see from building side, the left side is a physical building, and the right side is digital twin building. Similar, ditto, like whatever we have developed, it is there in a virtual replica in our system itself. So we are getting all the data from the physical building and monitoring, doing the analytics and all, and it automatically it is taking the decision and updating the things in the physical building. Okay. So digital twin, let's get some differentiations between what is digital twin, BIM and simulation. So generally BIM, I think आप लोगों को पता होगा, BIM जो है building information modeling, it happens during the design phase. Okay, when the building is getting designed or before the construction. Okay, construction भी नहीं हुआ होता, उससे पहले हमें उसका building BIM model बनाना पड़ता है, building information modeling हमें करनी पड़ती है. Then so it is a initial phase में होता है, उसके बाद हम लोग भी कर सकते हैं. And the simulation is being used to analyze or to during the design and to analyze the data. Okay, like once the building will be constructed, what will be the energy consumption or the water consumption, any things like will be there. But digital twin, it's not just specific to the design, it's for full life cycle. Design phase, or once the building is operational, digital twin is being used. Okay, if we talk about data, for the BIM as a static data, once you getting the drawings and all, the electrical, mechanical, civil drawings are in place, the data is static. Simulation, we do a lot of assumptions, like we take a lot of data from different codes, standards and all, and sometimes it being assumed like this will happen, this will not happen. Okay, but in digital twin, the data is being captured in a real time. Okay, so that is the main part of the digital twin. It's a real time. Whatever you are consuming, whatever you are using, the data is feed to the virtual replica, that virtual model. If we talk about decision, in the BIM is a very limited decision. Simulations, predictive decision, it has in the predictive decision, and digital twin predictive plus adaptive, like how you can optimize that, optimize the building and the operation. So that is happens in the digital. So that's why this is very popular or very important nowadays. Moving forward, the core components of our digital twin. The first is build physical asset, your building, your current building. That's a very important thing. Another is a sensors and IoT. I think people must be aware about the sensors and all. So जो हम लोग बोल रहे हैं कि वर्चुअल रेप्लिका उसके पास डेटा जाना चाहिए, तो वो डेटा के लिए हमें कलेक्ट करने के लिए we should have sensors to place everywhere in that physical building. So the sensors play a very important role for the digital twin. That data platform where we will be storing and analyzing, storing the data platform, analyzing the data, and the analytics and AI models will be there, and the feedback and control loop. So it's not a just it's not a one way communication, it's a two-way communication. It's from the physical structure to the feedback loop. Similarly, feedback loop gives the input to the physical building, automatically the data will be optimized. So it's a closed loop kind of a structure. Okay. So this is the very important. So digital twin works only when data flows both ways. Okay. So that's a very important part here. So BIM is a building information modeling. Okay. आप लोगों ने design MEP design का नाम सुना है? MEP design, like when we design a building, we do mechanical, electrical, plumbing designing. Have you people heard about it? Just say yes in the chat box. Okay. So when we design a building, I think, let's example in your home, okay, where the light is there, okay, where the electrical conduits are going on, okay. So how these have been planned? So during the design of that home or building, the MEP design is being created, okay. इसको हम create करते हैं. So it is being created by the professional electrical, mechanical, civil engineers जो होते हैं वो उसको create करते हैं, and they do in the Revit. Okay, I think आप लोगों ने Revit और आपने AutoCAD का नाम, AutoCAD tools people must be used. So AutoCAD में हम लोग design use करते हैं, और AutoCAD is one of the tool, but CAD tool, any CAD company tool we can use. Similarly, हम BIM की बात करें तो BIM is the kind of a building information modeling in a 3D structure, like how the building will look like in a 3D way, as well as from where that the electrical line will go. We can visualize the things in a different manner and from different angles. So that's where the BIM comes into the picture. So now the demand is huge in the BIM industry. Like if you are planning to make your career or want to learn more about the BIM, so that is very important in the building information modeling. Okay, so that's how it helps in the digital twinning also. So this is BIM. All right. Any questions till now? Anyone? Any questions? Please feel free to ask. You can unmute yourself, or you can put your questions in the chat box. I am watching all the questions. I am watching all full chat box. So we have Professor Dr. Ashok Kumar also. Good evening, sir. Okay. Anyone else? Any questions from anyone? Okay. Can I move forward? All right. All right. All right. Thank you. Let's move forward. So data sources in building. हम लोगों ने बात किया IoT और sensors का. But what data we require from the building? Okay. You use energy, okay, in your houses, in your buildings. So that energy data is very important. How much energy you are consuming in January month and February month, from whole year, on a daily basis, on a minute basis, how much energy you are consuming. So that data is being captured from that sensors, from your smart meters, that energy data, energy meters. Then HVAC sensors. Do you people know that 60%, 50 to 60% energy is being consumed in HVAC side of a building, HVAC systems. Have you people heard of HVAC? HVAC is a heating, ventilation, air conditioning system. आप लोग जो एयर कंडीशनिंग की बात करते हैं, हीटिंग सिस्टम की बात करते हैं, उसमें 50 to 60% एक बिल्डिंग में जो एनर्जी कंज्यूम होती है वो उस सिस्टम में जाती है. तो HVAC सेंसर्स इज आल्सो वेरी इंपॉर्टेंट. तो डेटा, उनका डेटा होना बहुत जरूरी है हमारे पास, उनको ट्रैक करना बहुत जरूरी है. Then we have occupancy data. Okay, how many people are living in that building? How many people are visiting in that building? So that occupancy, full-time equivalent data, as well as the visitors data, the occupancy data. Okay, that is also very important. And indoor air quality. What is the indoor air quality there, and also that data is also very important. And the weather data of surrounding. In which city, in which country, in which area that building is being constructed or is there. So that data is also very important. So these are the data sources of a building when we are making a digital twin or we are working on it. So each data source is a learning opportunity. Okay, so I would say it's a learning opportunity for each data source. इन्हीं के बीच में आपके बहुत सारे डेटा, जो आपको वाटर का डेटा अगर आप देखें, आपका मटेरियल का डेटा देखें, तो somewhere it is there itself. So that data is also very important. So these are the main data sources of building. So digital twin across building life cycle. Life cycle thinking is the biggest academic shift. First is design phase, performance validation. Okay, like during the design stage, जो building बनती है, सबसे पहले हम बनने से पहले we work on its design, like how will it look like, where it will be. Okay, so design stage, performance validation happens, like how the performance will happen of that building. Then constructions, quality and deviations check. During the constructions, we check what will be the quality and if any deviations, any gap is there, so that check happens. Okay, through digital twin. During operations, energy and comfort optimization. Like if we are consuming 100 kWh in a day, so through digital twin, how we can reduce, how we can optimize our energy consumption or the water consumption or air quality and all. So that can also do during the operation phase of the building. And the retrofit is what? When we change any of the system of a building. Okay, like if there's an old building, 10 years old building, and now you have to change your whole lighting systems or whole HVAC systems and all. So you do the retrofitting of the building. So that it's a scenario testing. So this is a very important thing. So these are the phases of the we can say the building life cycle. It happens in the first design, construction, operations, retrofit, or at the end there is one more thing. It's a demolitions. Generally, building is completed its life, 30-40 years old, then demolition will happen. Okay, so that's the main life cycle of a building. So why digital twins are critical for sustainability? Because I am from the sustainability field, and as you might be making your career if you are already in this area. So this is very important thing why it is very critical for sustainability and how the future look like. Okay, so energy optimizations, it's based on the real data, not the estimation. Okay, so that energy optimization is very important. Carbon tracking, I think you people aware about the carbon emissions. We should reduce our carbon emissions. So carbon tracking over time, like how much carbon emission is happening. Okay, through building operations. So that is there. Then third is reduced waste and over design. Generally what happens, people, they do over design their building, like put a lot of lighting, put a lot of air conditioning systems, but at the end they have to pay a lot of money to run that system. Okay, so they do the over designing of the system. So how we can reduce that and improve occupant well-being. At the end, it's all about person, it's all about people. If we are not able to provide the comfort, if we are not able to provide all the things to the people, they will not be productive. They will not be 100% fully satisfied. So that's improved occupant comfort is also very important. Okay, so that's why this technology is play a very important role, and definitely in the future it is going to be we can say the game changer. So energy performance and design intent to reality. I believe some of the things might be you thinking like this is new to you, but please note I try to make this presentation as simple as I can. But if you have any questions, any doubts, please feel free to ask in the chat box. I would be happy to share, and any questions we'll work it out. Okay, so energy performance from design intent to reality. Design says like during the design stage of the building, high performance, it should be the high performance, and operations shows when the operation happens there is a performance gap. So to close that gap, digital twin is required. Okay, so that's the importance of this from design intent to reality for this technology. Now give an example for HVAC optimizations. Are you people about the HVAC and all? Just give me the yes or no in the chat box. Are you people aware about the HVAC concepts and all? Just type yes or no in the chat box. Anyone? Just type yes or no. I believe if you are from electrical background, you might be aware about it little bit. Okay. No. Okay. So HVAC is a heating, ventilation, air conditioning. Okay. In a building, if I talk about in a building, uh, there is, I think in your home itself, and आपकी घरों की बात करें, आप air conditioning system use करते हैं, air conditioning आपके घर में है, तो that is the air conditioning which is a part of the HVAC system. Similarly, हम बड़ी buildings की बात करें, वहाँ पे heating system भी required होता है for water heating purpose. Okay. And ventilation, like if you have seen your parking areas, your closed building जहाँ पे आप एयर कंडीशनिंग नहीं है, वहाँ पे आपको वेंटिलेशन भी प्रोवाइड करना पड़ता है. पार्किंग एरियाज में जनरली आप वेंटिलेशन प्रोवाइड करते हैं. So that is a heating, ventilation, air conditioning. So HVAC is, we can say, the very important part of a building to for the comfort, like for the thermal comfort. Okay, so for the thermal comfort, it's very important. So उस सिस्टम को हम कैसे ऑप्टिमाइज कर सकते हैं, मीन्स उसको ऑप्टिमाइज करने की बात करें, उसको कैसे ऑप्टिमाइज करने के बाद उसका सिस्टम को भी हमें कम रन करना पड़ेगा, एज वेल एज हम उसको कम रन करेंगे, हमारी एनर्जी सेव होगी, एज वेल एज हमारा मनी सेव होगा. ओके, इट्स अ सिंपल वर्डिंग कि इफ यू ऑप्टिमाइज योर सिस्टम, इफ यू कैन ऑप्टिमाइज योर वर्क, you have to put less energy, you have to put less time. Okay, so that's how the similar thing happens in the HVAC system. हम इलेक्ट्रिकल की बात करें, इलेक्ट्रिकल सिस्टम में हाउ वी कैन ऑप्टिमाइज अवर इलेक्ट्रिकल सिस्टम, कि जहाँ पे हमारा डाउन टाइम कम हो जाएगा एंड रन टाइम ज्यादा, हमारा मेंटेनेंस हमारा कम रिक्वायर्ड रहेगा. ओके, so that's how you can optimize your things. So when we talk about the HVAC, predict load changes, कि आपका अभी आप एग्जाम्पल लेना समर टाइम, हम गर्मियों की बात करें, हमारा लोड कितना फ्लक्चुएट होता है कि हमें दिन में एयर कंडीशनिंग की बहुत ज्यादा ऑल्दो 24 आवर्स रिक्वायर्ड होती है कि समर है, बट समवेयर लोड चेंजेस मॉर्निंग 8 to in office building, it changes from morning 8 to 5 p.m. or 6 p.m. Okay, and that's how load changes because people लोग आते हैं ऑफिस में काम करते हैं, ड्यूरिंग दैट टाइम एयर कंडीशनिंग सिस्टम, लाइटिंग सिस्टम, वेंटिलेशन सिस्टम ऑन होता है, and that's how the system works in your home and offices. So how, if the system can predict load changes automatically, जो उसका set point है, जो system का set point है, I think आप लोगों ने देखा होगा in air conditioning systems we have a set point 22, 24, somewhere people set 24 degree minimum, जो हमें set करना चाहिए 24 रखना चाहिए, उससे ऊपर रख सकते हैं. So that is a set point. So similarly, अगर वो automatically वो set point set हो जाएगा कि as per the occupants numbers, as per the outside temperature, and as per the requirement of the people. So adjust set points automatically. It will help us to reduce energy consumption without affecting the comfort. So that's how it works. Efficiency without compromise. Okay. So this is very important part, like how we can optimize our HVAC system. So it's HVAC is one of the things. Similarly, the electrical system works. Similarly, our other systems in the building works. Moving forward, so एक example है physical twin and the digital twin. So physical building, उसका digital building, digital twin is a virtual replica is there, and real-time information exchange between the physical and the virtual, and condition monitoring, real-time diagnostic and predictive operations. It's automatically with the different language model it works, and that feedback is given to the physical building automatically. That system changes and optimize the data, optimize the runtime of the building. Okay, so this is how the system can be optimized. Okay, next is digital twins for occupant comforts and health. Now हम तो बात करते हैं, अभी हम लोगों ने HVAC systems की बात करी थी. Now we are talking about the occupants comfort and health. So occupant thermal comfort predictions, कि आप लोगों की यदि now I think you are in North India, there is a cold weather, okay, there's a chilly weather, you do not require air conditioning. So we know कि हमें इस टेम्परेचर की रिक्वायरमेंट है, हमें इतने टेम्परेचर पे अपना एयर कंडीशनिंग अभी तो चल ही नहीं रहा, बट हाँ अगर चलाते हैं तो what will be your required temperature. So automatically वो predict कर ले as per the outside temperature, and the similarly indoor air quality monitor, like current में बाहर की air quality क्या है, indoor की quality क्या है, and automatically it gives us input to the system, and adaptive lighting in the ventilation system. Lighting means during the daytime, okay, we do not require artificial lighting. We do not require our जो अपनी घरों में lighting लगी हो वो required नहीं. We can use the day lighting. अगर if we have a proper windows in our house, we can use the daylighting and we can reduce the energy consumption which is happening in our artificial lighting. And similarly, ventilation system. Like if we have a proper ventilation system, we do not require the HVAC or air conditioning systems in our building. So this can happen through different sensors, through different analysis, and this kind of a things happen through digital twin also. So human-centric design needs computing. So आप एक बार idea लगेगा कि how it will be working. And I'll show some example as well. All right, moving forward, predictive maintenance and asset life. Identify failures before they happen. For example, कि आप कोई सिस्टम अपने घर में यूज कर रहे हैं एंड उसका आपको पता चल जाए वो खराब होने से पहले, ओके उसका बिफोर उसका फेलियर होने से पहले आपको पता चल जाए, तो दैट कैन हैपन थ्रू डिजिटल ट्विन टेक्नोलॉजी. अगर वो पता चल जाएगा तो उसका डाउन टाइम कम हो जाएगा, खत्म हो जाएगा कि हाँ ड्यूरिंग द डाउन टाइम. जनरली क्या होता है इन द बिल्डिंग, recently I'm giving an example in my society. There was a bus bar, like for different towers there are bus bar, but they do the predictive maintenance so that in future अगर कोई प्रॉब्लम होने वाली होती है तो उससे पहले वो प्रेडिक्टिव मेंटेनेंस करती है, उसको क्योर कर देते हैं जिससे कि वो उनका जो रन टाइम है वो कम ना हो. सिमिलर विद आवर बॉडी एज वेल, अगर हम लोग पहले से ही उसकी केयर कर लेंगे so we will not face any sick and that issue kind of a things. So that kind of predictive health analysis and the maintenance and all, and it helps us to reduce the runtime and extend equipment life. Okay, so अगर आप किसी equipment की बात करें तो उसकी life बढ़ जाती है. So sustainability includes resource longevity, so that also happens in the system, this technology. Now, अब बात करें digital twins and net zero buildings. आपको पता what is net zero? Anyone has an idea what is net zero buildings? If you have heard about, just say yes or no in the chat box. Have you people heard about the net zero buildings? Anyone? Net zero buildings? Anyone in the chat box? I can see there are a lot of people on the call. No. Pooja is saying no. Anyone else? What is net zero buildings? Everyone, I need responses. Please have everyone help me with your responses. If you can unmute, you can unmute. If you want to respond in the chat box, that's absolutely good. Okay. So net zero, आपको मैं example भी show करूँगा net zero का. So a net zero building is that produces much as renewable energy on site as it consumes annually. Right. So net zero क्या होता है? Net zero energy भी होता है, net zero water भी होता है, net zero materials and all, anything can happen net zero whichever you talk about. But generally हम लोग बात करते हैं net zero energy की. Okay, कि हम अभी building से हम लोग ज़्यादा energy use करते हैं, so net zero energy and all. The energy which we are consuming in a building, जो एक साल में हम जितनी energy building में consume कर रहे हैं, उतनी ही हम generate कर रहे हैं अपनी building से through air conditioning, through renewable energy or through different energy efficiency measures and all. वो अगर वो आपका total year का sum आपका अगर zero आ जाता है, like whatever you are consuming and whatever you are using, or whatever you're consuming and whatever you're generating, if it is equal to zero, like आपका, then it say the net zero. Okay, in a whole year, not कभी आपका होता है कि जनवरी में आपका ज्यादा कंजम्पशन हो गया बट हाँ उतना जनरेशन नहीं हुआ, and it is fine. But in a overall year, if it is coming zero, then it is net zero. So that's the one thing. So I am very proud to share that हम जो हमारा office building है जयपुर में, we are, our head office is in Jaipur. So our own office building is a net zero building. Okay. So I will be sharing our picture also in last slide of the presentation. So continuous energy balance. कि जब हम लोग बात करते हैं कि हमारा कितना एनर्जी कंजम्पशन हो रहा है, उसको ट्रैक करना है, मॉनिटर करना है, और उसके अकॉर्डिंग वी हैव टू टेक अ डिसीजन. So continuous energy balance can happen. Renewable integration optimization, like how much energy is being required और कितना हमें जनरेशन करना है, so that can also happen. और कितना जनरेशन होगा, कितना हमें सोलर लगाना है साइट पे, कितना नहीं लगाना है, that you can track. And the real time carbon accounting means how much carbon you are emitting in the environment. So your building is emitting in the environment, that is a real time carbon accounting. Okay, so that can also happen. where AI and advanced computing fit in. So जैसा कि हमारी FDP का theme था advanced computing. So I thought you people are well aware about his recognition. Okay, like different patterns and all. कि हर किसी का एक pattern होता है. So through digital twin, the pattern recognition happens. Anomaly detection also happens. Like if there is a issue somewhere, then also detection happens. Predictive analytics, okay, like if that is going to happen in the future, usko pehle se analyze kar lena. Okay, so that is the predictive analytics. And the scenario simulation, so different scenario iterations we can call it, and different weather data, different requirements. So that is the thing. So digital twin is equal, we can, if you talk about digital twin, it's equal about data plus intelligence. It's not only about data, it's not only about intelligence, it's combined effort of both. So data plus intelligence, it's called digital twin. Okay, so if you talk about the industry adoption, a snapshot. Now, lot of universities, I think your university, the college is also NAC accredited, that NAC A plus I believe that accreditation is there. Similarly, many universities are now adopting sustainability. Okay, they are going for sustainability as well as now how they can optimize their data, optimize their consumption, optimize their resources. That is happening. So similarly, airports and hospitals are there, commercial green buildings, in the smart cities, and automatically it is helping in the smart cities. So this is already happening. If people are not aware about it, go check it out. Not many buildings are going towards it. And I'm giving you a snapshot of the market size. So digital twin technology is experiencing rapid growth in India. Rapid growth. So if you're planning to make your career, or if you want to work in this area, that's the right thing. Particularly in the infrastructure, manufacturing, and building management. So ज़्यादा हो रहा है वो infrastructure में हो रहा है, manufacturing में basically कोई product, कोई equipment बनाना है तो उसमें ज़्यादा होता है, and the building management to manage the buildings and all, driven by AI, IoT integrations, and sustainability demands. The market is projected to expand from USD $2.305 billion in 2025 to $63.41 billion by 2035. So in the next 10 years, you can see this is the demand is booming, and at a CAGR of 39.3% fueled by smart city initiative. I think many states have taken the smart city initiatives and predictive maintenance needs. Okay, so that's a demand, and it is already happening now. Okay, so this is the picture which is generated. Do you people know like from where I got this image? Anyone has any idea? Anyone? And because we are talking about advanced computing and all. So this is from various reports which I got from Google itself. And then I thought like, how should I present it? So you can see the BIM versus digital twin defining the shift. So BIM is for construction, twins is for operation. अगर हम लोग बात करें, BIM is the building information modeling. It's for the building during the building constructions, and twins, which is digital twin, is for the operational purpose. And snapshot versus living model. So BIM is a point in time reference, and digital twins evolve daily on a basis of continuous data. Okay, so you can see the 3 degrees of integration: manual digital models, automatic shadows, bidirectional digital twins. जो हमने बात किया, it flows do in both ways. The data flows, okay, and the on the basis the decision happens. So that is there. Okay. So now you will ask me, Anuj, you are talking about many things about digital twin, but what are the softwares being used? किसी के माइंड में ये क्वेश्चन आया कि कौन कौन से सॉफ्टवेयर यूज होते हैं इस चीज को करने के लिए? एनीवन? कि अभी हम बात करें डिजिटल ट्विन की, बट डेफिनेटली कोई ना कोई सॉफ्टवेयर तो यूज होगा इन चीजों को करने के लिए, इतने एनालिसिस को करने के लिए. Any questions on this part? Anything in your mind? Anyone?
So maybe for pictures, we are using some 3D models like CAD or maybe BIM.
Right. So I will be sharing. Yeah, very good,
Yeah.
Pooja. So what we are doing here, the digital twin software ecosystem, we will be sharing like discussing more things. So a digital twin is never one software. ऐसा नहीं है कि सिर्फ एक सॉफ्टवेयर हमको आ गया, हम लोगों ने उसमें सब कुछ कर लिया. It's not about just one software. It's an ecosystem combining modeling, data, analytics, and visualization. Okay. So अगर हम बात करें कि एक जगह सब कुछ हो जाता है, वो पॉसिबल नहीं होगा. एंड इट्स नॉट जस्ट अ सॉफ्टवेयर, इट्स एवरीथिंग. योर simulation, your data management, your whole analysis, and the visualizations, like as you mentioned, for the 3D structures, the CAD and all, that is there, but it's not just a one software. So what is there? So design and building modeling, फाउंडेशन लेयर. सबसे पहले हम जो बात करते हैं कॉमनली यूज टूल्स, आई थिंक आप लोगों ने सुना होगा रेविट का. दिस इज रेविट इज फ्रॉम ऑटोडेस्क. So Revit is generally being used. ArchiCAD is also being used, and the Bentley Open Buildings Designer. I think I have not used this thing. I have used these two tools, but these are the tools which generally used for designing purpose. The 2D, 3D designs, the building information modeling and all. We generally use Revit and all. Now, what is their roles of these tools? Creates the static digital model, geometry, system, materials. So we have to give the data accordingly. What is our requirement now? And the starting point, not the twin itself. अकेले वो twin का काम नहीं करते, but हाँ, it's a starting point. So BIM is a body, and digital twin is a body plus nervous system. हम लोग अगर normal language में बात करें तो BIM एक पूरी body है, but digital twin is body plus nervous system. अगर body में nervous system नहीं होगा तो it will not function. So that's a nervous system. That's a digital twin. Okay. So energy, performance and sustainability. अगर हम उसी बिल्डिंग्स में हम एनर्जी की बात करें, परफॉर्मेंस की बात करें, ऑपरेशनल डेटा की बात करें, सस्टेनेबिलिटी की बात करें, तो ये टूल्स जनरली हम लोग यूज करते हैं. एनर्जी प्लस, जनरली एनर्जी प्लस हम हो गया इक्वेस्ट सॉफ्टवेयर. आप लोगों ने इक्वेस्ट की सुना होगा. IESVE is very generally being used across the world. Design Builder is also one of the company. The tool is there. Okay. इनका रोल क्या होता है? एनर्जी, डे लाइट एंड थर्मल कंफर्ट, इनके एनालिसिस करने के लिए, इनका सिमुलेशन करने के लिए, परफॉर्मेंस प्रेडिक्शंस, व्हाट विल बी द फ्यूचर, व्हाट विल बी द फ्यूचर कंजम्पशंस, सो दैट वी कैन प्रेडिक्ट थ्रू यूजिंग दीस टूल्स. एंड द डिजाइन स्टेज इंटेलिजेंस, लाइक हमारी बिल्डिंग्स फ्यूचर में कैसी बनेगी, कैसा उसका कंजम्पशन होगा, उसको हम अभी प्रेजेंट में देख लेंगे थ्रू दीस टूल्स. वी कैन we can get the energy consumption estimates कि हाँ इतना energy consumption होगा. And we can optimize our designs कि हाँ हमें विंडो यहाँ लगानी चाहिए, लेफ्ट साइड विंडो हमारी इस फसाड होना चाहिए, इसका ये इम्पैक्ट होगा, इसको ये लगाने से इसका ये इम्पैक्ट होगा इन फ्यूचर. So that we can optimize our current building design. So that is the main part of generally these tools are being used. Okay. Then we have analytics, AI and advanced computing layer. So अगर हम analytics की बात करें, AI की बात करें, अभी now we are talking about the lot many tools, the AI itself, and the advanced computing layer. So we have Python, machine learning, MATLAB, then AI ML engines integrated with cloud platforms. Okay. The role of these tools are predictive maintenance. We can predict the future so that we can optimize our system, we can maintain our system, anomaly detections, and energy comfort optimization. So that is also there. The fourth is visualization. I think आपने third 3D का वो बात किया. Visualization and immersive experience हमें देखना होता है. Like this kind of a thing. This is the city, which is a virtual city, and the Unity. There's a one tool, Unity and the Unreal Engine. इनका role है 3D dashboards, virtual walkthroughs, teaching, training, and decision making. It helps in the different other things. Similarly, there are other tools which are being used. So this is the flow generally. Typical digital twin software stack is all about. This is for the building. Okay, it's not for equipments. It is not for any other things. I'm just focused on the building side. So Revit, Energy plus ISV, these are the tools. IoT sensors to get the data from the Azure digital twins, AI analytics, and the Unity dashboards. So that's how all things are integrated together, and we get our virtual replica of a building. Okay, that's called digital twinning of a building. Clear, everyone? Just type clear in the chat box if you are clear till now. Everyone type clear in the chat box if you are clear till now. Clear. Bhavya is clear. Other people? because we have more than 60 people on this call, I need minimum 10% responses. Okay, Pooja is clear, super. So that I can think, yeah, you are with me on this call, you are learning something new. Okay, Itha is clear, great. Other people, everyone just type clear, CLER, clear in the chat box if you are clear till now. And I'll show you some examples, some of the cities, some of the countries who are already working on it. All right, Mansi is clear. Super. All right, moving forward, let me just show you. So this is example of, let's say from our India itself. इंफ्रास्ट्रक्चर एंड ट्रांसपोर्ट डिजिटल ट्विंस. अभी हम लोगों ने बिल्डिंग्स की बात करी, बिल्डिंग्स तो एक है, बट इंफ्रास्ट्रक्चर में आपके ब्रिजेस आ जाते हैं, आपके मेट्रो टनल्स एंड ऑल. ऐसा नहीं है कि टनल हम लोगों ने आज सोचा और कल टनल बन जाएगा, ऐसा नहीं है. दे डू लॉट ऑफ एनालिसिस, कहाँ से क्या जाना चाहिए, कहाँ से उसका स्टार्टिंग पॉइंट है, कहाँ एंडिंग पॉइंट है, हाउ मच डीप वी हैव टू मेक अ टनल एंड ऑल. Everything we have to analyze through different data set. Okay. So Indian Railways Asset and Operations Digital Twins used for predictive maintenance, asset life management system, life cycle management, and safety assessment also. So that is also being used in infrastructure and transport as well. Now let's talk about countries. Okay, which all countries are using this kind of a technology and already used. Okay, so क्या लगता है कौन कौन सी countries हैं who are already working on it? Any example? I think I have showed one slide earlier. Anyone? Just type the country's name. Anyone? Okay, let me just show you. So we have Singapore, the global gold standard. We can say that global gold standard. So Singapore is one of the country. It's a very small country. Why Singapore stands out? Okay, the first country to create a nationwide digital twin. ऐसा नहीं उन्होंने एक बिल्डिंग का डिजिटल ट्विन बनाया, उन्होंने अपनी पूरी कंट्री और वी कैन से द होल सिटी, उसका पूरा डिजिटल ट्विन बनाया. ओके, नॉट जस्ट विजुअलाइजेशन, it is being used for policy planning and the sustainability purpose, integrated across urban planning, energy mobility and disaster management. आज हम लोग देखते हैं कि water level increase हो रहा है, there are a lot of rain is happening in some part of the India, a lot of there is a heat stroke in some part of the India. So how to get the data, how to optimize, how to predict the future कि कैसा कब कहाँ होने वाला है, so that also happens through this digital twin technology. Okay, so this is the country which has been implemented throughout the nationwide, and it is helping them to urban planning if they are planning any other establishment and all. So it is helping them mobility also, like they are doing a lot of smart mobility systems are there. So it is helping with them, and the disaster management, because there are a lot of disasters also happens at a lot of rainfalls and also similarly disaster management is also there. So digital twin is here is a governance tool, not a software projects. And let me just show you how it look like. So you can see this one, the virtual Singapore. So they have a country Singapore, and they have developed a virtual replica of it. So what it does, it simulates solar potential on every building. Like हर बिल्डिंग के ऊपर कितना ज्यादा सोलर पोटेंशियल है कि अगर उस पर हम लोग उस पर अगर सोलर इंप्लीमेंट करते हैं तो हाउ मच एनर्जी कैन बी जनरेटेड. ओके, सो दैट्स वन थिंग. अर्बन हीट आइलैंड इफेक्ट, आई थिंक आप लोगों ने हीट आइलैंड इफेक्ट का नाम सुना है. एनीवन? व्हाट इज UHI? एनीवन? जस्ट से यस और नो इन द चैट बॉक्स इफ यू हर्ड अबाउट इट. अर्बन हीट आइलैंड इफेक्ट? नो. एनीवन एल्स? ओके, तो अर्बन हीट आइलैंड इफेक्ट क्या होता है कि आपकी जो बिल्डिंग्स हैं, और अगर क्या होता है, आप गर्मियों में देखते हैं कि आप कंक्रीट जल रहा है, जैसे हमारी जो जनरली सिटीज हैं वो ऑलरेडी इतनी गर्म होती जाती है, तो वो उस पर अपनी सनलाइट आती है तो वो वहां पे कैप्चर हो जाता है. ठीक है, वो जो उसकी हीट है वहां कैप्चर होकर रह जाती है. दैट इज हाउ द अर्बन हीट आइलैंड इफेक्ट हैपेंस. ओके, So वो हम track कर सकते हैं through the digital twins की how where it is happening more, where it is happening less. So that is the one thing. Wind flow and ventilation. Okay, that's also very important. Ki how what is the direction of wind? What will be the how the ventilation system work? How it can be thermal comfortable for the people. So that is the one thing. Population movement and evacuation scenarios. Like in the case of the disaster, in the case of the fire, how the evacuation will happen. So that is also happens to simulate. And the supports carbon reduction and the climate resilience. So climate resilience is about if there is a in the future the temperature is increasing. So how the buildings are resilient to cope up with the temperatures and the climate. So that's the one thing. So that's a very I can say the best example country for the digital twin of infrastructures. Okay, so that's a very important thing. Another thing is so this is you can see that this is how they have developed the whole country like this, and this is the whole country like from the 3D views and also they have developed each and every building. So from the GIS and all also play a very important role in this, like where the next development will happen, how the impact of the different disasters and all, so they can easily predict it. Okay, so there's a one thing. The next country is Finland. So open and climate focused digital twins. So in the Finland, there's a one city called Helsinki. Helsinki. It's why it is a spatial open access 3D city model उन्होंने develop किया है and used for solar energy planning. How they can plan their solar systems and all, and how much energy will be generated. Carbon neutrality goals, like they have to achieve the carbon neutrality goals. Do you know that what is the goal of India for carbon neutrality? Anyone? In which year we have to achieve net zero? Anyone?
2040, I think.
Anyone else? What is the net zero goal of India? कब तक अचीव करना है? Yes, 2070. So 2070 is the goal. I think आप लोगों ने conference of parties. There is a one CUP conference होता है every year, and during the one of the conference, I think 3 to 4 years back, our honorable Prime Minister ji has set the goal कि इंडिया का जो net zero target है जो अचीव करना है, that is 2070, and it is we can say the अगर उसको अचीव करना है 2070, आज हम 2026 में है, उसको अचीव करना है, we have only we can say like hardly 50 years, अगर हम लोग बात करें hardly 50 years से भी हमारे पास कम है. Okay, 44 years हमारे पास है, but it's not just कि आपका एक साल में काम हो जाएगा. You have to take the decision now. Okay, so in India also a lot of things are happening, and as a consultant, as a sustainability professionals, we are doing a lot of things at our level. That is also happening. But other countries have set a target by 2040, 2050, 2060 also. Okay, so our target is very beyond. हमारा बहुत late का target है, but हमें वो काम अभी से करना पड़ेगा because India is a huge country. India is a huge country. So we have to, if we have to achieve it, we have to do from now. So lot many technologies, whatever we are discussing, that should be implemented now onward, and only it will be possible. So if we talk about the Finland, so carbon neutrality goals में उनको help कर रहा है, and urban climate analysis as well. Citizens, researchers, and students can access and use the data. That is also very important. Like they can use for their study, for their training, for their learning purpose as well. The next is so this is the kind of a city tool they have developed like this. So you can figure it out how the building will look like, where will be the water bodies, as well as how the system will work, and how everything is in place. All right, this is also the same 3D view of we can say the that city. The next is Dubai. Have you been? Have आप लोगों में से कोई have you been people visited Dubai and all? UAE, have you people visited? Just type yes or no in the chat box. Have you people been sometime Dubai? Okay, Dr. Isha has raised the hand. Okay, great. Anyone else? So Dubai is moving very, very fast. Okay. Dubai is moving very, very fast, and you won't believe they are very ahead of us. मतलब India से भी बहुत ज़्यादा आगे हैं. I think आप लोगों, if you have people visited, the rules and regulations are very strict there, and they also develop their digital twin. So smart city operations, like if we have to make our city smart, so for use for smart city operations, like आपका metro connectivity or new technology connectivity from where a new building. I think you have people heard about the building called Burj Khalifa. That's the tallest building on the earth, one of the tallest building of the earth. सबसे ज़्यादा बड़ी building है. तो उसके बाद भी they are bringing more taller building. Okay. तो उसको डिजाइन करने के लिए क्या होगा? तो it's not कि आपने डिजाइन किया और बन गया. They have to do a lot of analysis and all. So that's how the digital twin system works. Infrastructure optimizations, future ready urban developments, lot of development. I saw recent updates in Dubai. Lot of developments are happening. Okay, I think मैं जब Dubai first time गया था, that time it was in my mind कि हाँ Dubai is all about desert and all. Okay, I think लोगों ने देखा desert and all, but Dubai is far ahead of this. वहाँ पे desert भी है. They have ocean as well, sea as well as they have city, very great cities, Abu Dhabi and Dubai. So UAE is very ahead on this part. Strong integration with AI and real-time governance. So this is helping the real-time governance also, how the system will work, how the future will look like. I will also show some one video which I got from the Museum of the Future. Have you people that have heard about there's a one Museum of the Future in Dubai? Museum of the Future. Just say yes or no in the chat box. No. I would recommend go today, check it out on the YouTube, check out the video of the Museum of the Future. It's a museum there, and how the Dubai, actually mainly they were focusing on Dubai, how the Dubai will look like in 2071. And everything they have planned early. कि वहाँ पे कैसे होने वाला है, how the air taxi will be there, how the hyperloop will system will also be there. I will show you the one video there. So that's the planning already happened, and they are already working on it. And it cannot happen in just a pen and paper. They have to do through different designing and all system. So digital twin accelerate decision speeds in fast-growing cities like Dubai is one of them. So this is Dubai, and you can see this is Burj Khalifa. This is the downtown area, and it is not just developed design kiya 2D building brand. They have developed 3D structures. They have developed the digital twinning of the whole structures. कहाँ से कैसे connect होना है? Like there's a one metro station here, down Burj Khalifa metro station. वहाँ से आप Burj Khalifa or like they have from mall तक you don't have to go. आपको नीचे जाना ही नहीं. आप metro से connectivity है from the metro stations. That flyover is going there, and you can by walk you can reach out to that Burj Khalifa or that the Dubai Mall. So that's the best part happened. Early design they have made that कि यहाँ से वो connectivity होनी चाहिए, यहाँ से वो system जाना चाहिए, and that's how the infrastructure works. This is how the city. This is the downtown area. There's a we can say there's a one road, and there's the left side of the Dubai. This is the ocean and all, and this they have made a virtual replica. Okay. ये वर्चुअल रेप्लिका उन्होंने बनाया हुआ है कि इन फ्यूचर व्हाट विल हैपन, how all the buildings are consuming their resources and how they can optimize those buildings. Okay, that's there, and I would recommend you people should explore more about this city. And here, so this is a video from Museum of the Future. Okay, let me show you. This is the Museum of the Future video. You can see how it works, how it looked like. So see that so they have metro connectivity already in place, very good metro connectivity. Then they are planning the hyperloop system. Like it's a kind of a we can say the small areas or hyperloop which goes in a very fast speed from one end to the another end, and they have a air taxis. Okay, and they have a big building, and they are very focused on the sustainability. Okay, like उनको पूरा अपना city sustainable बनाना है, they are very focused on it. Okay, so this is the video all about that. And so this was the Dubai thing, but this is now I have come to the end, close to end of my presentation. So this is our building, our office building, and just the day before yesterday, we got an award from government of Rajasthan for developing our own net zero building, office building in Jaipur. Okay, so if you people sometime visit Jaipur, you people are most welcome to visit our office building. It's a net zero building. Whatever the energy we are consuming in our building, we are generating from our solar panels or other efficiency measures. Okay, so this is our office building, and we got the award from energy from the government of Rajasthan. So it's a kind of a model we have developed, and lot many students, lot many faculties from Jaipur itself, they regularly visit our building, and they kind of most of the people are making the case studies also, okay, for their thesis work and all. So that's how we have made a one best example for lot many people. So with this, I have come to end of my presentation. I think I'm before time, so we will be having 10 minutes for the Q&A. But before that, I would ask you, please, if you liked my presentation, if you learned something new, just scan the QR code and give your rating. How was my presentation? I request everyone, each one of you, just scan the QR code and give me a rating, 1 to 5 star, and how was your experience learning about digital twin, and how was the experience through, on this FDP from my presentation. So I will take a minute, and now we are open for the discussions. Any questions, anything, if you people want to discuss, please feel free to ask. Anyone? Any questions? We have 10 minutes for the Q&A. And it's not just limited to digital twin. Anything, any questions if you have from the industry sides, I would be happy to share. Can digital twins be applied to existing old buildings or only to newly designed? It is for the existing building. It can be for the existing building also. Like as I mentioned, it's not just for the new building. New building के लिए तो है ही, उसके साथ existing building जो already बन चुके हैं. We have to put the sensors there. We have to create a virtual replica of the existing building, and it can be done. So for the Singapore and all, they have done some part of the things they have done later also. Okay, so it can be done for the existing building. Anyone else? Any other questions? If any questions in coming your mind related to sustainability, AI and all, if you have, I am also, because I was just going through the FDP schedule of yours, I thought what should my topic. So I saw most of the faculties have taken that AI, generative AI and all. I also use a lot of AI tools, but I thought I should give you some different things from the different perspective from the industry side. So I put this topic, digital twinning, and I would recommend if you explore more on this thing, you can discuss later as well. But please take a moment, give me a scan the QR code, give me a rating from 1 to 5, and would be happy to like get your reviews as well. And another thing is, I'll be sharing this review with Jagriti. She will be sending you on the WhatsApp. But the next thing is very important. We have made a one community called the Green Gurus. Okay, it's very, very important community. If you're a student, if you're a faculty, if you're an industry professional, but looking to further know about the sustainability and all, this is a free community. You can scan the community, scan the QR code and join our community. If we have our platform as well as we have a WhatsApp community. So you will get regular updates happens through different mediums. So we have a WhatsApp community. You can join the WhatsApp group and you can get the regular updates about the sustainability, building infrastructures, and a lot many things. So what I would highly recommend, please scan the QR code and you can register for this community as well. So this is the second thing. How much amount of data will be generated from each building approx? So Bhavya, it's a lot of data. It's not, and it's a real-time data. It's not just a one-time data. It generates every minute. Okay, like I'm sitting here in office. So what is my energy consumptions every hours, and what is my water consumptions and all. So smart metering happens. आप देखते हैं ना कि automatically data वहाँ पे integrate. You have to refresh it, and it captures all the data. So it's a real-time data, and we cannot estimate कि कितना क्या होता है, but it's huge. It's a lot of data, and now the demand of the data centers are also huge because of this AI and this thing. So lot of data centers are coming in India. आपको अगर if you want to figure it out, in Noida itself, I'm in Noida, so a lot of data centers are coming in Delhi NCR and all. So the demand of the data centers, because a lot of data is generating, we are also generating a lot of data. We are using chat GPT and AI and all. So कहीं ना कहीं तो वो डेटा सेव हो रहा है, कहीं ना कहीं वो डेटा स्टोर हो रहा है. तो उस चीज को स्टोर करने के लिए वी नीड डेटा सेंटर्स, एंड उसके लिए आपको डेटा सेंटर्स बनाने पड़ेंगे स्टोर करने के लिए. सो the huge things are happening. Any other questions? Anyone? All right. So I would request, please join this community. It's very, very important, and you will get to know a lot many things once you become a part of the community. And hope you people have given the review. If not, I will share the QR code in the. I think Jagriti will share the group in the group as well. So she will share. Any questions? I think from someone. Someone raised hand. Okay. So the next thing is. You can, if you want to connect with me, you can scan this one. There is a tap on profile of mine. You can be in touch with me after this FDP as well. If you need any support, any questions, if you have, feel free to reach out to me. You can connect me on the LinkedIn. I'm very active on the LinkedIn. So if anything is required, that would be great. So that's the one thing. And with this, I have come to my end of my presentations. And if we are open, I think Jagati, if you're here, you can take it for lead.
Yes, sir. Hello.
Hello. Yes, yes, Jagati. Yeah.
Just a second, sir.
Sure. So I think people are here. I think this FDP is happening since Monday. So I just wanted to check how many tools you people have explored on the AI side. If I talk about AI and all, I think lot many sessions already happened in the AI generative AI and all. How many tools you people have explored it? आप लोगों ने कौन कौन से tool explore किया अभी तक? Anyone? Just put your tools name in the chat box. All right. Hearing none. Any questions? Anyone? We still have time till 7:30. If any questions, if you have, that would be, you can ask your questions. And I think someone there's a Google form also in the WhatsApp group. Please fill that Google form so that you can give the feedback in the Google form as well. And if you need for the presentation, I will also share this presentation with Neha ma'am as well as Jagati. So you will get the presentations from them. And yes, you can connect with me through, you can scan the QR code, you can connect with me. Jagati, are you here?
Yes, sir.
Yeah. So Jagati, I'm done with the presentations. Any questions, if anyone has, they can ask.
So dear participants, if you have any questions, so you can ask with sir. Please let me confirm if you have any.
No, I think Bhavya is clear. All right.
Okay, so I think no one has question. So, okay, sir, I would like to extend my thanks to you for
Thank you.
delivering such an insightful and informative session. And we truly appreciate your valuable time, knowledge, and the practical insights that you share with us today. Thank you so much for making this session engaging and enriching.
I think before we end the session, I would highly recommend if everyone can come on the camera. I'll take a one quick picture. If I'm
Sure, sir.
just everyone just please come on the camera. I'll take a quick picture so that I can also post on
हाँ,
my
picture बनेगा।
LinkedIn. Everyone, if you people can come on the camera,
हम लोग भी हैं।
let me just see who all are here. Yes,
हमें सीट-
I can see now the great faces. Super.
Yep, बोलता है yep.
Give me a minute. Everyone, just please come on the camera. I'll take a quick picture. Great. So we have Miss Pooja, Jagati is here. We have Mr. Puni, Mr. Patel is also here. Abhishek. Great. So let me just take a picture and 1, 2, 3. Thank you so much, everyone. I'll take one more. I think it's 1, 2, 3. Perfect, perfect. I have taken, I think, thank you so much, everyone, for such a great audience and hope you learned something new. Feel free to reach out to me if you have any questions after the sessions, after this FDP also, and would love to connect with you as well. Thank you and have a great further session. I think you have another session at 7:30. So, Jagati, I think they can have 5 minutes break, right?
Yes, sir. Sure, sir. And thank you so much, sir, again.
Thank you. Thank you, Jagati. Thank you, Nia ma'am. Thank you so much, everyone.
Okay. Okay, so I would like to inform to all the participants that the feedback form has been shared in your group. So kindly fill out that form as your attendance will be marked based on that only. So please ensure that you submit the form within the given time. And thank you for your cooperation. Next session will be start in 5 to 10 minutes. Okay, so now moving ahead, it's my pleasure to introduce our next speaker, Mr. Chandan Raj sir. He is a senior business analyst with over 5 years of experience in delivering AI-driven and data analytics solutions in the fintech and enterprise technology space. Currently, sir is working at ACIS Global, collaborating with data science, engineering, and business teams to build scalable analytics product. He holds an MBA in finance and business analytics and has worked with global clients like Dell, Intel, Johnson and Johnson, and TripAdvisor. He will soon be joining Arab National Bank, where he aims to drive digital transformation and data lead decision making. So, without further delay, I invite Sir to take over the session.
Yeah, thanks, Jagrati. Thanks for the introduction. So am I audible before I start?
Yes, sir.
Yeah. Let me know when my screen's up. Visible?
Yes, sir. Visible, sir.
Okay, good. Thanks. Here's how we will go. Firstly, I will take you through the slides, what I want to explain you people. And once I get it done, I will show you one small demo how things work with respect to RAG, and then I can take up the questions. Okay. So let me start with it. Yeah, even if you have any questions at a particular period of time, you can post it in the chat. I will take them at the end. You can give any heads ups or thumbs up if you're good to go. Okay, so I'll be starting. Yeah, thanks for that. So today's topic is we will understand AI in 2026. Basically, we are trying to understand how large language models and agentic AI works under the hood. So specifically, I will take you through how ChatGPT works and how we can make utilization of its capabilities to build any enterprise AI solutions. Okay. So what we will cover today here is we will try to cover what is AI, what are LLMs, and like from basics, and how ChatGPT actually works, its magic behind the curtain, and I will try to explain it in a proper way so that you people can understand. A simple walkthrough towards agent solutions. Okay. So coming to the slide one, what is artificial intelligence? So, okay, before getting started, anyone can unmute the mics if they have any questions. Like for now, how many people here do have the idea of how what is machine learning, what is deep learning, and what is Gen AI? Just wanted to have a rough idea so that I can take it. Anyone can raise the hand, or you can also paste your answers in the chat. You can unmute and speak. Okay, Puneet says he knows something. Puneet, may I know like what exactly you know with respect to like just a brief? Do you understand like what are the concepts of machine learning, deep learning, agentic AI, and its basics? You can just say yes or no. That's fine. Okay, Neha knows. Other people, you can raise your hands if you are not okay with speaking. Yeah, Abhishek says yes. Uh, so there are around 60 people. At least I need a couple of responses. Okay, Pooja, Neha. Okay, Ritu. Okay, I think topic ahead. So let me share my screen again. Okay. Now, first we'll try to understand what is artificial intelligence here. Now, there are two things. If like, there is a difference between how machine learning works, how AI works and how current agentic AI is working today. Okay, so if you want to understand how traditional programs work, it basically how human write exact rules, computer follows the rules precisely and same input and output. So if you want to consider traditional programming language, if you consider Python here, you write any code. So let's say if you want to calculate a factorial of a number, you just give a code and you give the input and you will get some output. So that is the traditional programs that we use. Now, what artificial intelligence does, how is it different from traditional programs? So it learns from examples basically. So let's say if you have a data set, so data set can be anything, a banking data set, diabetic data set, anything. Okay. So if you have a data set, firstly, it will try to understand how the data is. So it will go through each column. Let's say if you have some features. Now, here feature means columns. Okay. So features are like age, then your mobile number, your address, your salary, or employment details, etc., etc. Okay. So based on these patterns, it will try to find the relation between each feature, and finally there will be a target variable. Okay, so it tries to predict the target variable and make the decisions on that situation. That is traditional ML model. But in case of artificial intelligence, it will try to create some things. So if I want to explain you in simple words, okay, so basically there is ML, DL, and then in ML we have like supervised learning and then unsupervised learning. Okay, and deep learning we have ANN, RNN, and CNN. Okay, each of this scenario has its own use case. CNN is used in image classification. ANN and RNN can be used as sequence generators. Okay, and here supervised and unsupervised, there is a difference. Okay, so when I say supervised machine learning models, what they do here is, in brief, so basically you will have a data set. Okay, just for understanding, I'm telling you, you have a data set. So when I say data set, it will be in the format of, let's say, okay, let me create one data set. Okay, so let's say we have some employment details. Okay, so we will have some columns, let's say name, then gender, and then salary, then address. Okay, so this is kind of a data set. You will have some data about each employee. Okay, and there will be a target variable. Okay, so now target variable can be anything. Let's say salary can be. Okay, so considering this a target variable. Okay, let's say address, then mobile, um, experience. Okay, now if you see, okay, and does anybody has question? Okay. So can we do AI with Python language? Okay, Anusha, Karthik, can I take the questions after I finish the things? Okay. Let me cover some topics since I have like around 15 plus sites. I need to cover up things. Definitely, I will take the questions. Okay, at the end. Let me cover a few things and then you can post the questions. I will take everything at the end in the chat. So I was here. Now, this is a data set kind of thing. So based on this data, we will try to predict the salary. So let's say we have name, gender, mobile address, and experience. So as we all know, if you have the domain knowledge as per the experience, and I think we can add another column here, qualification. Uh, right? The people's salary will vary, right? So based on this data, when you dump it into the machine learning model, it will try to predict the salary. Okay. Now, in case of machine learning models, this is known as supervised machine learning model. Okay, where you have the labeled data. That means you know the input and you know some expected output. That is, the traditional ML model where you do the things. So that is supervised. Okay. So I won't go into the depth. I will just like brief you about the things. Now, when it comes to unsupervised, right, you don't have these labels. Of course, you will dump the data directly. You will directly dump everything, considering salary also. Now, internally, what will happen in unsupervised learning algorithm is, so it will take these features one by one, and it will try to group it as per the similarities, or let's say it forms the clusters. And based on these clusters, it will give us the output. That is unsupervised learning. Okay. Now, when it comes to deep learning, we have RNN, CNN, and ANN, and then which will work on the principles of transformers. Okay. And transformers works on the principles of self-attention. Now, this is in depth actually, so we might not cover up in detail, but you need to understand transformers works on self-attention, and also we need to understand encoder and decoder architecture, which is needed for to understand the GPT working. Okay, so I will take you through this at the end. Okay, so coming back to the slide. So traditional programs are fixed. Basically, if you want to understand, you will have the input and output. But in case of artificial intelligence, it will try to learn the patterns on its own and then makes the decisions. Okay. So in case of this is ChatGPT and the image recognition. Okay. Any questions for now? Okay, cool. So moving on to the next slide. Now coming back to what is large language model. So as the name suggests, if you see here, these large language models are trained on billions of pages of information. It can be anything: text, books, websites, and articles. So currently, these LLMs works on basically web scraping. So when I say web scraping, all the data that you search using Google, it is being scrapped, and that data is being trained on the LLMs so that they are up to date with respect to the today's world. Okay, so firstly, large in the sense the data is huge basically. And when I say language, it understands and generates human language. It can be any language. Okay, English, Spanish, whatever you name something, that language it can understand. Basically, a translator kind of thing. And model is there is a math behind everything. Okay, so any machine learning model you take, it works on some math principle. So for starters, if I want to tell you, it is, let's say, linear regression models works on the principles of y is equal to mx plus c, wherein it tries to find out the best fit line and get the predictors. Okay, so this is a mathematical pattern which is very much needed for an LLM to work. And in simple analogy, if you see, imagine someone who has read every book in the world. When you start a sentence, they can predict that words might come next based on all the patterns they have seen. That's essentially what LLM does, but with math instead of memory. Okay. Now there are parameters which acts as your tweaking things. Basically, you can tune these parameters as per the output that you need. Okay, and the data that it is trained on is huge. Okay, and languages also supported are huge. So basically, how things happen behind the hood of an LLM is, you train it on the large corpus of data. It can be considered, for now it can be a text data. Now this text data, it is converted into an embedding. So when I say embedding, it is basically converting your textual data into a number format, and it can be of different dimensions. Okay, so, and once it is converted into dimensions, it will also tag it with metadata if you want. Okay, metadata in the sense, let's say region, locality, anything, so that it understands how we can group those data. And once it understands the patterns, it tries to predict the next word based on whatever user input gives. So when I say in user input, let's say you are using GPT, right? You give an user prompt input, in the sense a prompt. So you want to know the capital of India. So you ask GPT what is the capital of India. So first it will go and search its training data. What is the capital of India? Then it will have the knowledge of it and it will come up with a response. Okay, so that's how it works. So that response is basically a token generated from a large corpus of data. From this simple analogy, you can think about it, how it might generate. Okay, now how does an LLM learn? Okay, So first we gather the data. So it can be anything. You can take anything on the internet that you can train an LLM on it. Okay, and it start learning patterns based on that training data. Now input can be the sky is usually. Now model learns blue is very likely, green is unlikely. So based on that corpus of data, right, it might know different colors. Okay, but it needs to understand its context that the sky is usually. So sky needs to be blue. It cannot be green, right? So based on this context, it will give the probability to this blue word, green word, and whichever has the highest probability, it will generate that next token here. So at the end, blue will have, let's say, 0.78% of probability, and green might have like 0.2, and there might be red also, which will have like 0.4. So out of that, the highest probability word is chosen, and here it will fill that pattern. Okay, and in the end, it will give the output as the sky is usually blue. Okay, now when I say fine tuning and specialization, so there are different domains that are available. So if you consider e-com domain, fintech domain, right? So based on each domain, you want to train your LLM. Okay, so since LLM has a wide range of data, it might cross mix the data from each domain. Okay, so that might be a problem, because if you're working in a medical industry, you want to have a correct information. Okay, so what happens here is sometimes LLM might hallucinate. So when I say hallucinate, it might give you an answer with such an confidence that even if it is wrong, it might say it is correct. Okay, so that is the reason we fine tune it. I say fine tune it, we train it in such a way that it will understand that particular domain knowledge, and it will give you that correct answers. There are various ways to judge this fine tuning models. You can evaluate it keeping a human in loop also, and you can also different as a judge there. Okay, so once you fine tune it, you will deploy it, and once it is deployed, it end user can use it. Okay, so that's how an LLM will be able to learn. Okay, but here you need to understand the training time here. If you're trying to build your own LLM, it will take around weeks to months, and that too on supercomputers. This forget this supercomputers, but your compute, whatever you are building your LLM, needs to be very strong. It needs to be good enough so that uh, it trains faster and faster. If you don't have a proper compute, then it will take, if it needs to be trained on weeks, it might take months. Okay, that depends on compute. So training time is huge, and cost, as per you also know, you might have heard from Sam Altman also, it's billions and billions in dollars. Okay, the training cost. A simple ML, it will take around an hour to run if you have huge data set itself. So yeah. Now, coming back to how ChatGPT actually works. Now, ChatGPT is an also large language model, and it works on the principle of decoder architecture of transformer. Now, when I say transformers, it is basically consider something which can help you understand things, or uh, uh, get an input and create an output in a specific format. Okay, so it has two components. One is encoder and decoder. So ChatGPT works on the sole principle of decoder. Okay, so here decoder only predicts the next token. It doesn't have the context of future token. So when I say this, right, future token, how it will take your question is, so if you say what is the capital of France to GPT as a prompt, it will take what first. It will not have the context of is the capital of France. These entire sentence, it will not have the context. Next, it will understand is. Next, it will understand the. Next, capital. Next, of. Then France. And finally, once it understand its entire context, it will try to generate the next token after France. Okay, and once it has the token, it will phrase that entire into a proper response. So it might say the capital of France is that. Okay, so that is how it takes into consideration. Now, how the process happens behind the word. So text become numbers. First, your what is the capital of France, they get it into number format. When I say number format, those are vector embeddings. So vector embeddings again are into different dimensional format. So those dimensions are first. So first, your textual format is converted into vector embeddings, and those are like tokens. Okay, So first, your text is converted into token, and those tokens are converted into vector embeddings, which the computer can process. And then it is passed through neural networks internally. Like, let's say normalization happens, then positional encoding happens, and then you pass it through some activation functions. So when I say activation functions, there are many activation functions. One is softmax, sigmoid, ReLU. So these activation functions works on probability, that is maths behind it. Okay. So when I say softmax, let's say consider this example. What is the capital of France? It might have different things like Delhi, Paris, etc. Okay, so each word or the each token will get some probability if you are using softmax as a function. And if you use sigmoid, it will have only two tokens. So sigmoid is basically worked on biclassification, and then softmax is used for multi-class. Okay, so based on that, it will give you the finally the capital of France is Paris. Okay, and everything this will happen in 1 or 2 seconds of time. This is known as latency. Okay, so if the latency of your LLM model is very high, then at the end user who is consuming at the end, right, it will they will suffer the web loading and response time also. Okay, so this latency needs to be as low as possible when you're deploying your LLM model. Okay. Now, here, if you see how the word is predicted. So ChatGPT predicts the most likely next word, then the next, until it forms a complete coherence response. Now, if you give the input, the cat sat on the, now it will come up with words. So those are known as top key responses. So it will come up with mat, chair, table, roof, and more. And whatever you see these numbers, right, 90%, 60%, 40%, 15%, those are nothing but the probabilities. So the word which gets the highest probability will be filled here, and you will get the output. Okay. And one thing you need to know that whatever LLM model or the, let's say, GPT itself you are using currently, it doesn't know the facts. It just barely predicts on patterns from its training data. Okay. You might think that it has the reasoning knowledge, but it doesn't. It is just trying to find the patterns based on the mathematical logic, and it will give you the answer. Okay. So this is the core concept how ChatGPT works. Any questions? For I think it's too much. Can take a few. Okay. So let me proceed ahead. Nextly, we will try to understand the tokens here. Okay. So what is a token? A token is a piece of text, could be a word, part of word, or even a punctuation mark. The AI breaks everything into tokens before processing. So whatever input you give as a prompt, it will be split into tokens. Now, if you see this sentence, right, ChatGPT is amazing. It is splitting chat and GPT into two words. And is next word, amazing is next word, exclamation mark is next word. Now, these are total 5 tokens. Okay. And why tokens matter is the amount of context window per LLM is limited. Okay. And it is limited because of tokens. Now, API pricing is based on tokens used. So how many tokens you are using, it might depend. So if you are using free version of ChatGPT, it might be, let's say, around, just an example, okay, it might be able to produce 2000 tokens. But if you have the subscription of ChatGPT Plus version, it might produce 4000 tokens. That is basically an amount of response that it can generate, or a context window per session. Okay, that is how the tokens are important. Okay, now more the tokens it will generate, more processing time it will take at the end. Okay, in general you can consider as 750 words is equal to 1000 tokens, and these words might be chunked in the sense it might be tokenized into different formats. Now this is like a word chunking. You might have the para chunking, sentence chunking, document chunking also. Okay, and GPT-4 context is up to 128,000 tokens, and typical conversation will generate around 500 to 2000 tokens. Okay. Now you need to understand neural networks, the brain of AI. So how these system works is there will be an input layer, there will be hidden layer. Now in this hidden layer, you will have your entire thing, that is encoder, decoder, and all the pre-processing, that is right from converting into tokens, chunking, and then embeddings, and then normalization, positional encoding, then passing through the activation functions, and finally giving us the probabilitical response and generating the output. Okay. So these hidden layers are many. I have shown only 4 or 5 here, but it will be like many hidden layers, and it will take the amount of processing time. So basically, the input from here will pass to H2, H3, H4. It will be like permutation combination of your neural responses. And once these inputs get to understand the patterns passing through the hidden layers, it will try to generate the output. Okay. Now, in generally, human brain has 86 billion neurons, and neural networks will also have like billions of neurons. So these are basically the neurons, okay? And parameters are basically their training parameters. So if I want to name something, some parameters, there is random state, then n estimators, n trees, max depth, and there are many. Okay, L1, L2 parameters are also there. So there are these parameters are also there, and also number of features on which it is trained on. Those are also considered as parameters. Okay, so this is the concept of neural network. Now, what can LLMs do? So whenever I say LLM, you can also consider ChatGPT as an LLM. Okay, so they can help you in conversation. So basically, answer your questions, have natural dialogue, provide explanations. They can create the writing material, let's say blogs, emails, articles, stories, and any other marketing copies that you're doing. They can also help you in coding, the write, debug. So if you see the VS Code extension, it might have some inbuilt tools also. You can also use some AI tools which can help you the debug the code. I think Cursor is one of them. You can try to use it. It will be very useful. Okay. And then translation. So you can also use large language model to translate from one language to another. Let's say English, Hindi, Marathi, Kannada, French, anything. Okay. And analysis. So currently, if you see the ChatGPT extension, it will have the upload button also, where you can upload the documents, directly ask it to give the insights and analyze the data. Now, just for cross-checking, let me say this: whatever answers all these LLMs gives, they might not be 100% correct all the time. Okay, you just need to cross-check it always. Okay, and sometimes the knowledge that an LLM have may not be up to date. So let's say when initially ChatGPT was released, it had the knowledge till 2021. Okay, at that time, if you ask anything post September of 2021, it couldn't answer. It would give any vague answers. So now it is up to date, but yeah, whatever analysis it gives, you need to have that one doubt whether it is correct or not. Okay. It can also give you creative tasks, brainstorm ideas, write poems, create content strategies, etc. It can also help you in teaching, right, like explain concepts, tutor students, provide step-by-step guidance. It can also create a study plan if you want to help your students to get it into proper format. It can help you gather the research papers also, and you can also compare them and also ask it to provide recommendation. Okay. Uh, uh, in brief, LLMs are versatile general purpose tools, not specialized for one task. Okay. Uh, but you can create an LLM for specifically one task after fine tuning it for a specific domain knowledge. Now, with advantages, what LLMs can do, there are also LLM limitations and challenges. So, as I told in the earlier section, hallucinations. So, what happens sometimes? It makes up the facts completely wrong. Okay, like it might create you invent fake research papers and statistics. Okay, now that you have seen ChatGPT, it will give you its content basically. So whatever you research or give the prompt, it will take you through, it will give some web URL option. I think you can look into it. So if that URL is content, that means it's created by its own. Okay, those are hallucinations. And then knowledge cutoff. So training data has a cutoff date, doesn't know the recent events. That is knowledge cutoff. Then math and logic. Sometimes it might struggle with complex mathematics. And then there is context length. So if the token limit or the context window of whatever response it is generating is limited, then it will have the limited memory of it. Okay, so basically, one session might have around 2000 token limit. As per the subscription, it might increase. That is context length. And then comes the bias and safety. So can reflect biases from training data, needs careful monitoring. So once you train the LLM, that doesn't mean it is able to understand all the training data. There will be some bias and error there. So you need to evaluate it on proper grounds, fine tune it to get a proper output so that your evaluation matrices show the good results. And then you also need to consider safety standards. So if you see, people nowadays blindly upload their photos and videos and whatnot onto Gemini or ChatGPT format. You are literally helping platforms train using your data, and their database are all have your knowledge. Okay, so basically, whatever you do with an LLM, firstly, it is storing that data. Secondly, it is training on that data, and thirdly, it is upskilling on data. Okay, so whatever you do with respect to LLMs, GPT, or whatever things are there in the AI world today, uh, don't just use them blindly. Do focus on your safety concerns, how you need to use it. Okay, and sometimes it might not have no real understanding, so doesn't truly understand, just start matching content. That's it. Okay, and as a note I have mentioned here, always verify important information from LLMs. They are powerful but not perfect. Okay, so these are some of the limitations of an LLM. Is you can also consider GPT. It will also have. Okay. Now coming back to agentic AI. So any doubts so far? Let me know if my pace is too fast. Any doubts? Okay, let me take that as no. Moving to what is agentic AI? Okay, just give me a minute. Okay, next we will try to understand what is agentic AI. Okay, so one is traditional LLMs that we use. So those are nothing but your ChatGPT, Gemini, and other large language models that you have. What they can do is you can ask question as a prompt, it will give an answer, and the conversation ends there. Okay, those are nothing but traditional LLMs that we use. For example, GPT, as I said. Now, agentic AI is basically it can take the decision, but at the underhood, it will also have an LLM to help it out. Okay, so let's say you give it a goal, it will break it down into steps, and it will AI takes actions to complete it, and adapts if something fails. So let's say you want to order something on Zomato. Okay, so you can build an application. I think it is already there. You can just give a prompt that you need a pizza. So how it will do is, first it will break your prompt into different things. So you need a pizza. So it will take the restaurants that serve pizza. It will show you which are the top based on the ratings, and then it will take you through the payment gateway also. And if you are using wallet, it will automatically pay the amount, and it will make the order itself, and the order will be delivered. Okay, so this is how agentic AI works, which LLM lacks. Okay, so that is the reason people are moving towards agentic AI. But to take this or to understand the prompt that user gives, this agentic AI will take internally the help from LLM. Okay, and that is known as an agentic AI. Now, key difference between agentic AI is agentic AI doesn't just answer; it acts, and it can use tools, make decisions, and work towards goal autonomously. Now, here tools is an important term. When I say tools, those are nothing but an API endpoints or and functions that specifically use for a particular use case scenario. So in our case, let's say here payment gateway is a tool. Showing restaurants based on ratings might be some other tool, and finally ordering it might be some other tool. Okay, so those are nothing but different functions which are split into different things for different category that is needed, and then it will do the task. Okay, so those are agentic. Now, how these works? Okay. Firstly, they'll understand the role and current situation. Here they have given the example of book a meeting with a team. This, if you give to Gmail, it won't give you because it doesn't have the access to your email, your calendar, and other things. Okay. Next, what it will do? Okay, so basically, first it will understand, then it will break down the goal into actionable steps. So it will check the calendar, find the common time with the participants to and from, and then it will send the invite. Now it will plan these things and then it will act. So it will execute the plan using available tools. So here, if you see tools here, access calendar API is a tool, create meeting event, and then send emails. Now this sending emails, so just giving an example, here SMTP protocol is used to send an email. So this can be used as a different tool. Okay. So all these tools club together with an understanding of your prompt till the execution of this act will be performed by an agentic AI. Okay. And check if the action is succeeded, adjust if needed. Now it will try to execute this action. Okay. And if it fails here, it will re-loop it again and it will try to see where it has gone wrong. It will try to have any other approach. It's like it is thinking. Okay. And then it will execute your task. Okay. For example, if it is saying if time doesn't work, try another slot. So basically, if the calendar is full with respect to some uh, person and he is an important person, it will try to find different slot with respect to his availability. Okay, so that is nothing but the loop how agent works. Now, agentic AI tools and capabilities. Agent needs tool to interact with the code. Now, web access is one of them. Email and communication is one of them. File management, you need to give an access. Code execution, API and integrations, database access. So all these are different tools, basically, if you consider. And if you give this access along with an LLM, you will create an agentic AI. Okay. Now, example of agent workflow. Your goal is to research our competitors and create a summary report. Okay. Now, what it will do, it will first use web search to find competitor websites. Then it will fetch and analyze the product page. Next, it will query internal database for our pricing. Then it will create a comparison document, and then finally it will email the report to the team. Okay. So this is how the entire workflow happens. Next is where you can use a real world agentic AI examples. Okay, you can use it in customer service agent where you can handle customers' inquiries end to end without human intervention. Many people have adapted to this. You can also receive some phone calls actually, which are literally using agentic AI solutions. There is no person behind the call; it's just an agent talking to you. Okay. Then data analysis agent. So let's say if your report is continuously the same based on same pattern, you can just create an agent around it. And once you dump the data, it will pull out the data and give you the reports automatically. Okay. You can manually set up this and you can schedule this. Okay. This will also work. Then HR recruitment agent. Now HR people have a lot of job right from shortlisting till the hiring until in between some steps like scheduling the interviews, getting back to the clients and also to the interviewer. Okay, so these things also can be automated, like passing the resume, match candidate job requirements. So LLMs are quietly used here in passing the CVs to get the best fit candidate for the requirements. And scheduling the interviews also is done, and then sending up follow-up emails. Like most of the things are getting automated in production also. Okay. In financial planning agent also you can create like monitoring finances and providing proactive recommendations. Okay. So these are some real world examples where agent AI can be used. You can think of any other things that you can build and you can try creating a POC and then create it on the last scale. Okay. The future. So agents that handle entire workflows from start to finish. So people are trying to go towards this. Okay. Now, the final point, which is building with AI in enterprises. So, why enterprises are adopting AI? One is the repetitive task which can be done is automated, and secondly, it can work 24/7 with no stops. And it is also cost reduction. It can increase the efficiency. There is innovation and insights, better customer experience. Okay. So everything, if you club together, you can create a good enterprise solution and scale it and productionize it. Okay. Now, some of the common enterprise AI use cases are like customer support, email and document passing, HR and recruitment, sales and marketing, business intelligence, code generation and review, training and knowledge management, compliance and risk. Okay. So compliance and risk, some of the procurement folks are also using some of the AI tools to get the compliance check on the documents that they have. Okay. So you can think of any other solutions where it can be used, and you can also try towards building it. Okay. Now, how to access AI? Different options. How you can access AI? When I say AI, it can be an LLM or an agent. Okay. Use pre-built AI products, like use existing AI services through web interface, like we use, that is ChatGPT, Google Gemini, Claude, etc. It is best for quick start individual users, no coding needed. Okay, that is option one. Option two is use AI as an API. Now there is something known as Grok, which which you people can try, which is a cloud interface. You can directly pull the LLMs from there as an API endpoint and directly plug it into your code, and you can use it. Okay. Integrate AI capabilities into your own applications via APIs. Examples are OpenAI API, Anthropic API, Google API, Azure Open API. Now these are best for integration, developers, scalable solutions. Now, third option is a bit costly. It is build and host your own model. So you need a good compute for this, and I think good cost. So train and deploy custom AI models on your own infra. That is Llama, Mistral, custom fine-tuned models. One way also to do this is download the existing LLM model and fine-tune it as per your need. Okay, that would be the best option here. This will give you the maximum control, data privacy, and specialized needs. Okay. So most enterprises start with option two, that is APIs, which is easy, that is balanced and flexible to use. Okay. So these are some of the ways that you can access the APIs, or sorry, AI. Now, if you want to start your AI journey, or if you want to build something out of AI, so first you need to identify the use case. Okay. Find the repetitive tasks or processes that could benefit from automation. Start with low risk, high impact areas, and then you can think of a business problem. Once you find the problem statement, experiment with a prototype, try with existing AI tools, test with APIs, build small proof of POCs, that is basically. Fail fast, learn faster. So once you try to create POCs, you will definitely have some blockers. Once you solve those blockers, you will understand how entire thing end-to-end works. Okay. So once you understand it, you can directly scale it up. Okay. Also, you need to convey the clients if you're building it for them, and then you can scale it up. Next is measure and iterate. So this is an important part. So you track the performance of whatever deployed things are there. Okay. You gather the feedback from the users and then continuously improve it. So it's like maintaining it on, if you're maintaining it on weekly basis, monthly basis, depends when your data changes. Okay. And then scale what works. So expand successful pilots across the organization. So once it is deployed and it is stable for a particular duration, you can scale it or try to build a different solution based on the same idea. Okay. One thing is needed once you're entering into the AI world, to learn continuously. You need to collaborate, which, and these 3 points they stand true in any case. Okay. Prioritize, prioritize security and ethics. Okay. So this can help you build something. Now, key takeaways. So LLMs are nothing but pattern predictors. So they predict the next word based on the massive training data, not true understanding. Now, agentic AI takes action. So the feature is AI that doesn't just chart but completes entire workflows autonomously. Now, enterprises are also transforming. AI is reducing cost, increasing efficiency, and opportunities across industries. So at this particular period, if you have good knowledge in the field of AI and machine learning, you are at spot. But don't just stop there. Keep yourself updated. Keep continuously learning. Curiosity will definitely make you a good person. Okay. Always start at small and then scale smartly. Begin with simple use case, learn from experiments, and expand what works. Okay. So the question is not if, but how you will leverage it for your organization. Okay. So yeah, I think I have covered most of the things. So any questions? I can take it up now.
Sir,
Yeah.
sir, I'm having one question that
Yeah, buddy.
how do the LLMs decide what information the agent should receive?
Okay, so basically what happens here is, okay, let me share my screen. Okay, so how things work here is, we have an agent, but it will have all the things like tools, API endpoints, DBs, etc. Okay, but whenever, let's say you are a user, you give it an prompt. Okay, so first it will do the same things. Okay, it will basically, this agent will have the support of LLM. Okay, and LLM in the sense, let's consider here GPT only. Okay, and now this GPT will definitely have all the knowledge based on the training data. It will know based on the prompting techniques basically. So prompt design is important here. So you design a system prompt in such a way that the answer that user needs in a proper fashion. Okay, so based on this prompt design also, you can make an agent answer in a particular way, or make use of tools in a better format. So let's say you are giving a prompt like, summarize me this document. Okay, now in the prompt what you will give here is, first of all, give key points like this, like, no, let's say introduce the document, and then give 5 key points, and then finally key takeaways. Okay, and you might also give an example here how you want your output, like in the JSON format or any other format. And once you give this as a prompt, right, this entire thing from here, from introduction the document till here, this will work as a prompt. Sorry, this will work as a prompt here, from here. And based on this prompt, your agent can take or perceive how it will answer the question. Okay, is it clear?
Yes, sir. Thank you.
Yeah. Any other questions? No worries if the question is lame. Uh, every question is worth explaining. So even if you have any question, just please ask. Uh, you can also put it in chat. No worries if you don't want to speak. But yeah, I'll wait for 5 minutes. If no, then we can close the session. Okay, who designs the prompt? So basically, one who is developing the prototype or the POC, he will have the designing of the prompt the way it is needed. You can have the prompt designing in different ways. One is zero shot, few shot, and no shot at all. So when I say no shot, it will not have any examples. One shot will be have one example, and few shot will have multiple examples. And then there is chain of thought. So when I say chain of thought, you will explain it how you want the output. So basically, the developer who is designing the, or writing the code will definitely design the prompt. Any other questions? What are system prompts? Okay. Okay, so those are the prompts that you give basically to a system. So let's say your agent acts as a system here. So you give the agent to behave in a specific format. Those are system prompts. Okay. You can also have different prompts for different scenarios. Like let's say you have three prompts for three different use case or scenarios. You can club them together and you can ask the system as output. So system prompts are nothing but you are asking that particular agent or let's say if you are clubbing two agents together, each agent will have its own prompt, right? So those are nothing but system prompts. Oh, any other questions? Okay, so why do LLMs hallucinate and what is the best way to reduce hallucinations? So one is temperature that can be used when you're training an LLM. Lower the temperature, better the response is. The higher the temperature, it is a parameter, okay, temperature basically. So you can have if you have the higher temperature, your LLM tries to get creative, okay. So you can have a good temperature that is around 0.5 to 1, which will make it in its threshold. Basically, it will rise LLM or restricts LLM to give the better result, stick to the training data. And next is you can update it regularly, basically train it or update on the things. Temperature is basically a parameter. So there are parameters on which the model is trained. Okay. So I will show you one example at the end. I have a demo ready. And okay, so coming back to hallucinations. So you can have it updated. You can also build a RAG system around it so that if it hallucinates, it goes back to RAG and retrieves the good info. Is it clear, Vivek? Yeah, okay. Any other questions? Okay, so if you have any questions, have it ready. Let me show you one simple demo, which I built a RAG system here on my local machine. Is the screen up? You guys can give thumbs up. That would be great. Okay, device is okay. Now, yeah, thanks, Neha. Okay, cool. So I have built a RAG pipeline here. So let me give you a brief context here of what I have built here. So basically, I have built a RAG here. So RAG is nothing but an retrieval augmented generation. So it will store the documents into vector DB. Consider this as an database. Pardon me if spelling mistakes happen. So once the user gives prompt here, it will go and fetch the information from this RAG vector DB. It will create a response and then it will modify the response using an LLM. Okay. So this is how the structure is. Okay. Let me show you the working. Okay. So if you see the architecture here, I have app.py wherein it is using Streamlit here. There is a RAG pipeline wherein the things are there, and then there is test.py if you can use it for a unit testing. So in RAG.pipeline, we have major things here. One is if you see it in the embedding model, which converts your tokens into vector embeddings. Then I have downloaded the model from Ola uh, and fine-tuned it. So this is the temperature here. If you see 0.1 I have given here, you can give anything up to I think 1. So based on this temperature, it will create your responses. Okay, and these are the parameters when I say. So temperature is 1, top pay is basically it gives the top probability to that word. Okay, number of predictions, repeat penalty. So penalty is basically to reduce the repetition of what it generates. Okay, so this is something known as Tama. I'm pulling the L model here. And Tama DB here acts as our DB wherein it stores information. And then load documents is we load documents from a system. And then chunk here. If you see 3000, if the length of the document is less than 3000, I'm chunking it into 400 words with 80 overlap. That means to have the context of next things. Okay. And based on that, I have chunked it. And then vector store I have created. and then set up a QA chain. So this QA chain is basically your question answering chain. And here search thing is K is 4. So basically top K results are given here. Okay. And this is when I say prompt here. So this is how the prompt is given by a developer. And this is in the format of template. So it says answer the question based on the context below. Be concise and accurate. And this is the context. So context is nothing but your input. Question is from the user and it wants the answer in this format basically. Okay. Now, yeah, I think most of the code is that I have used cache here so that any repetitive query is given, it will doesn't pass LLM again and again. It will take it from the cache LLM. Okay. So first we need to run Olama. Okay. So once it starts running, okay, let me check if it is running. So this we need to check before, and this is the URL. If you see here in the code, this is the URL to check out Olama. The point from which pulling the LLM model. And the model is pulled in, I will run it, using this app.py basically, using streamlit run app.py. So if I run this, it will open here. Okay, so let it load here. I want to show you this. Okay, so this test.txt is a file. Okay, I can load PDF on test. So basically, I can load PDF and test documents here for now. I have given just this content. Okay, now how this works, let me show you. Let it load. Now this will also increase the latency. Okay, so your loading time also matters. So that you need to work upon. Basically, I need to work upon, but yeah. So everything needs to be considered when you're deploying anything into production. Okay. Since it is on my local machine, it might take some time because system features matters. Okay. Okay, if you see here how things are working here, loading a main model, so model is loaded, then Hugging uploading which is counted, and then everything will go up here. Okay, so this is the interface here. We have coded it in app.py. So it is basically an UI design. So Streamlit is used here to design your UI. You can design it the way you want. Okay, you can also cache the layers for anything. Okay, these are just the information which UI has. You can ignore those. The main component is this. So if I browse the files here, I have this test information which is opened here only. I'm uploading it here. Okay, I can click on process document, but if you see here, it has some information regarding retrieval documentation. Now, once I click on process document, it will internally process everything. First, it will what it can do. First, it will chunk these documents. It will throws this into vector.db along with some information. And once it is having information, whatever the user query uh, gives the question here, it is ready. Okay, so it will basically go and research search that vector.db. So basically, when I give the prompt here, it will come into Chrome. Now it has stored the entire chunking here. Okay, come here, search it, and based on the top key results, it will give the answers. Okay, so I can directly give on summarize also. If you see, it is analyzing this document internally. Test. Okay. Now, if you see, it has given 3-point summary here. Here's a 3-point summary. Retrieval augmented generation improves accuracy by accessing, and it has also given the sources here. If you see, it is entirely the same thing what is there in here. Okay. Now, if I just ask it what is here, it says based on provided context, RAG most commonly refers to retrieval augmented generation, an AI technique, which is from here only. See? Okay. So based on whatever information it gives, it has its sources, and it might generate based on these sources. It can also create the response based on the this. Okay. So internally, it is creating this response using the LLM, but it is retrieving everything from the vector databases. These are the sources basically. So based on these retrievers, it will generate the response. Okay. So this is a simple RAG interface wherein an user uploads the documents here, and based on documents, your chatbot works. So this you can use it in your internal organization wide, wherein you train the RAG system of your own, and it can act as a KT session. So basically, any new joiner joins in, he can ask the questions directly here about the project workflow, and it can learn from there only. Okay. So this is the simple use case I have shown you. Okay. So hope you understood something from here. Any questions for? What are quantized models? What does quantization mean in LLMs? So quantized models are nothing but you are trying to reduce its size basically. So let's say you are trying to decrease the precision. So some of the models might have the output or the vector embeddings in the format of, let's say, 0.0000, something like that. So these precision can be decreased from one point to another. So you basically quantize the models. That means you are trying to reduce its size. That is what I think. Then how can we use RAG in other scenarios? Yeah, you can use RAG in many other scenarios, whatever you can think of. So one is, so for now I have built a chatbot using a company policies. You can use a RAG basically in an organization to train your own LLM model. So to have a ground truth, basically, you can build around that something. And then I think you can also store the images in the vector database. You can improve the accuracy of the hybrid search also. I think there are many ways or many scenarios. Is chatbot a RAG? No. Chatbot uses RAG system to answer your things. So chatbot is just an interface or in UI design. So RAG is working behind the hood. So as I showed you, right, this interface, whenever I asked it, what is RAG? So that interface is a chatbot, and behind the hood, vector database, retrieving the things based on the user query is everything is RAG. Okay. Any other questions? What are your device's specs and recommended specs for learning AI? Okay. One thing is you need to, for starters, if you're building something on your local machine, at least you need to have minimum i5 processor, or I think Ryzen 5 with RTX 3050. I think that works. And minimum of RAM you need to have is 16 GB. So once you have these things, I think you can build pretty much many things using the machine learning. Also, you can try using APIs and other things. You can directly pull in into your local system and you can work around it. What is a roadmap? Okay, I think we are moving differently towards different topic. But yeah, I can send the roadmap, Sagar, if you want. In general, if you want to start the roadmap, first try to understand Python, SQL, ML, then go towards deep learning, then try to understand transformers architecture, have the knowledge of RNN, ANN, CNN. And I think that's pretty much about it. I just have one cloud also to understand how things work in the deployment. That works. Any other questions, folks? Okay, I think we don't have any other questions. Jagriti, if you're there,
Yes, sir.
yeah.
So, okay, sir. So, on behalf of the organizing team, thank you so much for such a wonderful session.
Yeah.
And your session was literally insightful and very engaging today. And your knowledge and perspectives were truly valuable. And thanks to all participants also for their active involvement and enthusiasm, which made today's session meaningful. So now, as the session has concluded, I kindly request all the participants to please switch on their video cameras for a group photograph. Bhavir, is it done?
Yes, it's done.
Okay, thank you. So thanks to everyone. Thank you, sir, for your time and for your session,
Yeah,
and to all the
thanks.
participants also. And we look forward to seeing you tomorrow on time for the next session. And a reminder that attendance is mandatory for all and will be marked through the feedback form only, which is shared in your group during each session. And thank you once again. Have a great day ahead.
Yeah, thanks everyone.